Tutorial 1, Question 6. In each of the following, the numbers have been obtained by measurement. Evaluate each calculation to an appropriate level of accuracy. Well, before we do any calculations, let's make an estimate of what we think the answer is going to be. We've got 11 times 9, roughly, 99. Let's round that to 100. And that's going to be divided by 5. And the numerator is multiplied by 001, which is the same as multiplying the denominator by 1000. So that's approximately equal to 1 over 50, which is equal to 0.02. Now if you put the numbers into a calculator, you'll get the answer 0.024001, which is close enough to our answer so we can be confident that we've got that part of it right. So the next question is, how many significant figures have we got? We've got 3 here, we've got 2 here, 3 and 4. So 2 is our minimum number of decimal places, so that means our answer is going to be 0.024. Part B. Again, we're going to estimate what our value is. We've got effectively 0.3. We've got 3 times 10 to the minus 3 divided by 9 times 6 is 54. Let's call it 60 to make the numbers easy. Okay, so that is equal to 3 over 6. So let's simplify this a little bit. That's 3 times 10 to the minus 3 divided by 6 times 10. 3 over 6 is going to give us 0.5, and that's times 10 to the minus 3, and then there's another one there, so that's minus 4. So that's going to give us 5 times 10 to the minus 5 as our estimate. If you calculate the value, you'll get an answer of 5.8498. 6 times 10 to the minus 5. So that's reassuring because it's not very far from our estimate. So the next question is, how many significant figures have we got? There are 3 here, 2 here, 3 here and 4 there. So 2 is the maximum number that we can quote. So we're going to round this up to 5.8 times 10 to the minus 5. Part C. Let's make an estimate of the value. We've got 13 times 7, which is going to be about 100, and that's divided by 100th. So effectively that's multiplying by 100, so we've got a little less than 10,000 here, and we've got 9,000 here. So we're expecting these numbers to be roughly similar. If you do the calculations, you'll find that the first part of the expression is actually 8,647.33 recurring minus 9,015. So that gives us an answer of minus 367.66 recurring. So the next question is, what is our minimum number of significant figures? And it's this term here, which is only 2. We can only quote this number to 2 significant figures. So if we round this up to two significant figures, we're going to get minus 370. Part D. Let's start by estimating the value. 18 times 2 is 36. 3.6 times 0.5 is about 2, so let's call that 34. And that's going to be divided by 8 times 3 is going to be 24. 6 times 9 is 54, so that's going to be about 70. So it's 34 over 70, which is approximately a half, is what we're expecting. Then if you do the calculations, you're going to get 0.463376, let's say. Okay, which is about a half, so that's reassuring. The next question is, how many significant figures have we got? And they're all to 2 significant figures. So we can only quote this number to 2 significant figures, which means that our answer is going to be 0.46. Question 7. Write each of the following in preferred standard form. Preferred standard form means the exponent of the 10 is a factor of 3. So in the first one we've got 6.1 times 10 to the 7. The closest factor of 3, the closest number that's a factor of 3 would be 10 to the 6. So if we reduce this by 10, we need to increase this by 10. So the answer here is going to be 61.47 times 10 to the 6. Part B, 2.439 times 10 to the minus 4. 10 to the minus 3 is the closest preferred number. So if we increase that to 10 to the minus 3, we need to decrease that. So the answer there is going to be 0.2439 times 10 to the minus 3. Part C, 5.2861 times 10 to the 5. Well, obviously 10 to the 6 is the closest preferred exponent, so that would give us 0.52861 times 10 to the 6. Or if we prefer, we can move the decimal point 3 places this way and call that 528.61 times 10 to the 3. Both are acceptable answers. Part D, we've got 4.371 times 10 to the minus 7. 10 to the minus 6 is the closest preferred number, which means that we're increasing this by 10, which means that we've got to decrease this by 10. So the answer in that case would be 0.4371 times 10 to the minus 6. Question 8. Determine the following products, giving the result in standard form. Again, before we start, we'll make an estimate of the value we're expecting. So we're going to get roughly 6 times 7 is 42, times 10 to the 3 and 10 to the 4. So that's going to be 42 times 10 to the 7, which is 4.2 times 10 to the 8. Okay. Put the numbers into a calculator and you'll find that the answer is actually 4.73 times 10 to the 8, which is near our estimate, so we can be confident that that's a right answer. Part B, we've got minus 3 times 5, which is going to be minus 15. We've got 10 to the 3 there and 10 to the minus 4 there, so that's effectively 15 times 10 to the minus 1, so that's going to be minus 1.5 is our estimate. If you do the calculations, you'll find it's minus 1.69, and that's times 10 to the 0 if you want to be correct in standard form. Part C, we've got 7 divided by 6, which is a little bit larger than 1. That's 10 to the minus 4, and we're going to be dividing by 10 to the minus 3. So it's something slightly, it's about 1, it's a bit bigger than 1, I don't know, 1.1 let's say, times 10 to the minus 7. If you do the calculations, you'll get 1.19 times 10 to the minus 7. Okay, so we can be confident that that's a reasonable answer. And then finally, for part D, we've got 4 times 10 to the 3 divided by 9, so that's roughly 4 over 9, which is about 4.5. 10 to the 3 divided by 10 to the 4 is going to give us 10 to the minus 1, so we're going to get 0.05 is our estimate. And then if you do the calculations, you'll get an answer of 4.64 times 10 to the minus 2. So if you go 1, 2, that's in line with our estimate, so we can be confident that that answer's okay as well.